Okay, let me solve one more problem about the interpolation. Interpolation, in fact, is very, very important numerical analysis. But before that, I ask you please subscribe to my channel and try to watch the videos online. Let x0, x1, 2, xn be n plus 1 distinct points. And q of x be a polynomial of degree n with x0, x1 to xk minus 1 of degree, it should be k, not n, of degree k. Okay, let me fix it. Of degree k with x0, x1 to xk minus 1 as roots. It means that q at x0, at x1, and at xk minus 1 will be 0. Okay? And k less or equal n. Now, I want to show that q of x is equal to sum I equal to k to n q xi li of x. Okay, this is the problem. Now let me try to solve the problem. Okay, by the assumption we know that, which assumption? This part of assumption that says in fact x0, x1 to xk minus 1 is roots of q of x. Okay, we know that q at xi equal to 0 for I equal to 0, 1 to k minus 1, right? This is the assumption. Now, let me consider p of x the interpolant polynomial for q of x. Now, let p of x be the interpolant polynomial for q of x at which points? x0, x1 to xn. Okay, so it should be, let me consider p of x, it should be equal I equal to 0 to n q of xi li of x. Okay, but we know that q at x0 is equal to q at xk minus 1 equal to 0. Okay, so it will be sum I from k to n q xi li of x. Okay, so p of x is to this form. Now we have to show that p of x is equal to q of x. Okay, to this end we consider the error term between q and p. Okay, so now consider the error term E of x equal to Q of x minus P of x. Okay, let me compute this error term. Let me rewrite E of x equal to Q of x minus P of x, and this will be equal by the, in fact, the theorem about the error term, it will be pi I equal to 0 to n x minus xi times n plus 1th derivative of eta over n plus 1. But we know that q is a polynomial of degree k, okay, and k is less than or equal n. So the n plus 1th derivative of q is 0, okay, but we know that degree of q is k, and k is less or equal n. So qn plus 1 derivative of x is equal to 0. So this term should be 0. So this is equal to 0, and this means P of x equal to Q of x. Okay, so this means P of x equal to Q of x. Now you can put here instead of P of x, Q of x. So Q of x equal to sum I equal to k to n q of xi times li of x, and this complete the proof. This is all. It's not very difficult problem. It's easy to solve, but you have to know just something about the, in fact, error term. Please subscribe to my channel and wait for the more problems. Thank you and wait.